I mentioned would be basically addressing an important part of every translator, like used in programming languages or in computer systems rather. Now, these symbol tables really play an important role in the whole implementation of the translator rather. Now, when we do talk about symbol table, major aspect would be how exactly we are going to go about designing the same. So if we at all try to define this, if you recall, we used two commands rather to get information from the object code rather to like find out information about the symbols. Like we used nm and we used readelf and then we displayed symbol tables in -s option for the executable as well as for the object code. Now, how exactly we are going to define this part? So this would be definitely like if I try to relate it with respect to a table concept or relation concept in databases, same idea can be enforced here. Like there would be some set of attributes related to the program. Now, what this symbol table is supposed to do? Symbol table will associate attributes with the identifiers that are used in the program. Correct. Now, like when we go about that particular aspect, what would be kind of attributes? Say, for example, there would be a type associated with every identifier. So that identifier probably could be name of a procedure. OK, it could be name of a variable. It could be name of a constant even. Correct. So it can vary. Now we have seen that like whenever we are talking about this data type aspect, majority of programming languages do have support with respect to type. Okay, where the types are differed in respect of their implementation internally. How many bytes would we use to represent or to store value of for that identifier with the specific type? Now, even few other languages are there. Like for example, if I talk about Visual Basic, so it provided a data type where that data type doesn't hold any particular type of value. It can be any value. So depending upon the value that is passed, it can proceed with respect to storing it. That means what in terms of implementation perspective of that type, it basically addressed how many bytes would be used. Correct. Now, if you really see all the data types supported by majority of programming languages, there are specific types having number of bytes associated. For example, integer 4 bytes, small integers 2 bytes, correct. Float 4 to 8 bytes, correct. Character a byte. Whenever you wanted a string kind of data, then you used or it forces you to make use of arrays. Correct. So like this definitely would be varying from programming language to programming language or translator to translator. Now this is one of the important topic, rather not important component of every translator. Symbol table would be an important and necessary component for every translator. Now the reason being definition or a declaration of identifier is always found in this particular table, provided that that identifier is available in the code, in the program that you have given for translation purpose. Another thing is like it definitely can let you know information about where exactly that identifier may occur or appear at what place inside the program. Correct. So that means what we are talking about a scope perspective. Correct. Now think of this like if suppose there are two procedures written and both the procedures are containing some variables. OK, now though we say that local data would be going to stack, how about the other types of variables like which are local, which are global, which are static, which are dynamic? So they may go at a particular location. Some of them would be going into dynamic memory, correct, from heap. Some of them would be found in the stack. Some of them would be definitely stored in a specific data part provided with the programming language. Now, these this information of symbol table is important in perspective of the whole process of the translation, which will in turn go through the type checking mechanism. It also can go through with respect to to find out whether the variable is defined or not. If you recall, we used extern function and then we said extern printf. And when we tried finding out printf entry into a symbol table or object symbols rather through enum, we found that it is containing u. You mean to say like that is not found, undefined kind of stuff. So you definitely wish to make use of symbol table to verify what are the identifiers used by the programmer inside through definition or declaration. Are they available in the symbol table or not? Or if it is available in symbol table, then you are going to find out whether it is there inside the core or not. Correct. So we definitely require information about the context where this name would be valid. What are the variable that you used? What are the identifier that you used is valid or not? Now, when we do talk about operation perspective, what would be the basic operations applied on this particular symbol table? So like if I talk about a data structure. Now, when I say data structure, it could be like in general, we say it as abstract data type, correct? So whenever there is a type associated, there is a set of operations also available. So like with respect to the symbol table, major operations can be seen as search, insert, delete. But let us try to elaborate it more. Let us say first talk about, okay, whenever a program is given as an input to the translator, we definitely require a mechanism which will create an empty symbol table. So I'm defining an operation called allocate, which would be used to allocate a new empty symbol table for the program. Secondly, I may have a delete or a free operation, okay, which would be used to remove entries and free the storage. Okay, whenever it is not referred further. If it is referred, whenever its lifetime comes to in the scope of course scope's perspective, then ultimately you are going to add that data. Third thing would be like insert. Insertion would be adding a new symbol and then returning that position or a pointer from the data structure to communicate what is the position or entry point of that symbol into the symbol table. Then other option could be search, or sometime you can call it as lookup. This would be used to search a name of identifier inside the table, and then as a return value, it would be returning pointer to its entry in the data structure. Now, few other parameters probably could be like, for example, if I say, let me make use of, say, for example, Excel. Suppose this is my symbol table, and if I have, say, name, okay, as a parameter, say, for example, if I go about like having columns defined, okay, so what possible columns could be, like if you recall, I asked in previous session, what would be the different columns that you may expect rather for a data like a student, say, for example, their attributes can vary. So let me think of this. So let me say it's type. Okay, let me say its size, defined slash undefined, where, so I'm talking about scope. 1 minute. Let me increase this font size. Okay, so suppose if I say this is my symbol table, correct? Now, like when I enter a symbol, say for example, I found printf, its type is function, size not known. Okay, it is now currently undefined. Scope also is from text section. Okay, now when I say this, ultimately, whenever I link the code and this I found this printf is found, then this whatever u is there, this should be replaced with d, correct? So when I'm making this change, I need to know what is the current attribute value for a particular attribute associated with that column or with that particular symbol. So that's why I'm thinking like, why not have two more operations even defined? One is set attribute and other one is get attribute. So get attribute would be like, suppose you got a variable, say for example a. It is of type, say for example, say let me define, say for example size. So type is no type, size is say 4, and I'm saying here u. Okay, and then I'm saying this is available in text. Now when I say it is u, that means what? This seems to be a label, correct? Because this a, when it is found as u, or you might have written it as extern. Now whenever I get a symbol a, and whenever I'm trying to add that entry over here again, then I will verify, search into this table whether a entry is available or not. If it is not available, then I will add entry over there. That's what happened with this a earlier, correct? But if it is found, then I should not have another definition. So that's why you will see an error, kind of like multiple definitions. So the values for this column would be defined, undefined, or multiple defined. So this will help you out to really throw the errors which can be used rather at the time of translation or before the translation, before generating the object code. You may throw this error like multiple definitions found of the symbol table. So let me demonstrate that part using Teams. Let me join, say for example, from the Linux machine. Let me add a terminal. Okay, and let me now share the terminal. So is my terminal visible?
Yes, sir.
Okay. So let us say, suppose if I define a code, Emacs 170821.asm. Now let me define this section.text global main jump LP. Okay, and first statement itself is jump label. Fine. Then I'm saying I'm adding some instructions here. Move ex comma ebx, increment edx. Something I'm defining. Fine. Let us try to translate this. NASM dash APLF 32 1708. Okay. And if I press enter now, you will see that the symbol LP undefined. Fine. If I try to generate that LST file, say for example dash lp.lst, then even it is giving me this error because whatever the definition that we used or whatever the definition we are considering here, it is trying to find out this label intuitively. Now suppose if I add extern LP, okay, as a symbol. So let me try to now assemble this. So let me remove this. Now if I see, I do get an object code generated there, correct? 17.8.21. So if I try to display now 17.8.21.0, you will see that this LP entry is found with you. This is undefined because you wrote it as extern. Now suppose if I say 18, sorry, 17.8.21 underscore 01. Okay, now if I say section dot text, sorry, global LP, and if I say, if I use this, say for example, fine. So I wrote a code where I added this entry, correct? LP. If I try to translate this now along with this NASM, I assembled it. Now let me assemble this one also. So I got both of them generated. Now let me link together both of them. 17.08.21.01 dot O 17.08.21 dot O dash M32. Now you will see that like if I now display this nm dot a dot out, try to find out that LP. Now you will see that it is T. Correct. That means what it is resolved. Whatever the reference that was added there, it got defined. So when I said in earlier example through the table that I was showing you, rather, you must have seen that what when my entry was U, in this case undefined, when I found it, I'm not I'm not replacing it by D, but ultimately the text where exactly I found it. So I found it in text section. So that value is getting added there. Correct. Similarly, let me show you another aspect where we can see that there are multiple definitions available. Fine. So let me go with this now again back to Linux. So we are adding code now, Emacs. '21. Now here, if I say LP, suppose if I write this, okay, let us try to work with this. I have external LP, I wrote jump LP, and then this is the code. So if I say nasm dash f elf32 1708 dot asm. Okay. Now if I try to write this 170821 dot o. Now you will see that it is getting this T defined over here. Correct. Now let me link together both the dot O's again. We had already that one created, and this currently after update we created. Now you will see that there is an error. Multiple definition of LP. Why it happened? Because let us see this code. 17.asm. You will see that we have defined a label here. So this is talking about its context. Scope is defined here. Its scope is local. But here you said extern, but it never worried about it. Like while comparing, while linking together both the things, it found that another LP was available with this. Correct. So this undefined suddenly became defined, and then it is found at two places. And then that is what the error was. So it said multiple definition of LP. Now how it will get this information? Because it must have searched. It must have searched the symbol table. So that's what I was talking earlier about. Like if at all we do search the symbol table rather to get information about the attributes available over there. Okay, so in that situation, we will define two operations. One operation is set attribute, other one is get attribute. The one method that we use to manipulate this earlier entry of U to D, this was get set attribute. Another operation that I was talking about, like whenever you found another LP, then you found okay, it seems it is there. So you are trying to get value for this particular attribute. So that's what set attribute is. So set attribute and get attribute you would be making use of perspective. Now when we do talk about this I'm not saying that your symbol table will look like only this. Correct. It can have multiple parameters. It can have different columns too, different attributes too. We don't know. Like at the time of implementation, your mechanism might change. But if at all we are planning to say design the symbol table, okay. If at all we are planning to design this symbol table, then what would be another option for me? What would be another options for me? So I may go with multiple design techniques. So let me talk about first unordered list. Now here I am mainly focusing on how to insert and how to search the names. These would be my two parameters for implementation techniques. Now if I talk about the unordered list, it is one of the simplest mechanism to implement. So you can implement it through an array or a simple linked list. Okay. Now advantage with linked list would be what? It will be growing dynamically. But problem then is, like if I have a fixed size array, if I use array, say for example for unordered list, problem is my array size would be defined. So say integer symbol table of 20 or struct, and then I'm defining that structure with 20. So this would be limited. So this problem of defined or fixed size of array can be moved out by making use of linked list over there. Now, if you talk about programming perspective, it is one of the best technique. Rather, programming perspective, if I talk about how much effort I need to put, so coding would be very easy, but searching would be one of the worst thing. Like for example, if I have insertion would be very fast, order of 1. But when I'm talking about search operation, it is too slow. That means what? If I have n elements, I definitely will require probably order of n on average to search that particular table. Correct? Using this unordered list. So probably I can get advantage of insertion to be very fast, but the problem would be with respect to like say for example search. Okay, so let me find out another alternative. So another alternative for me would be what then? Okay, let us make use of ordered linear list. So basically you say ordered list. Now what I will do here, I will take this symbol whenever I add entry into symbol table over here, I will first sort that and then I will try to find appropriate position for that case. Correct. Now if array is sorted, then it is very easy. Like I can make use of searching using binary search. So order of log n would be required with base 2. Correct. But how about insertion into a sorted array? We have to find out position of it, and that's what would be one of the expensive task. Similarly, deletion would be another expensive task. Now, when it would be very easy for you to make use of such kind of structure, say for example, like if I have to make use of ordered list, it would be very easy for me to use whenever I have predefined steps. Like for example, if I am trying to design my own opcode table, then I definitely will prefer to make use of ordered linear list or ordered list. Okay, but anyway, like that would be your design logic rather. What one would be better for you? Third approach probably could be BST, binary search tree. Now this can grow dynamically. Like you are combining your linked list with this ordered list in some form, where now it would be organized in a tree structure. Correct. Here insertion and search would be order of log n. Okay, even deletion would be on the same manner. But problem here is like if at all I am asked to define make use of this or binary search tree, then I know how much difficult it is to implement. Now when I say how much difficult, I definitely need to find out some solution. Correct. So I may go with binary search trees. One another option probably could be a hash table, and that is mostly used by assemblers. Almost all the assemblers or all the translators that you see, almost all of them make use of hashing technique rather, or hash table to store information about or store this or create this symbol table. I'm saying mostly used, commonly used probably the proper term. Now what is that hash table? Hash table is what? You have an array, okay, which is very large. So I'm defining this in terms of n. Say for example, my index may range from 0 to my table size. Suppose if my table number of variables are n, then my hash table would be order of index range would be from 0 to n minus 1. And when I go with this, I definitely need to define something called as hash function to implement this. Now how this hash function should be? Now your hash table built procedure would be heavily dependent on how efficient your hash table function is, or sorry, hash function is. Now what we can think of, let us think of this way. Now what are the hash function we are going to define? This hash function will be mapping an identifier name to its table index. Now how exactly we can come up with this? Now if I try to define this hash function that way, then ultimately it will be solely dependent on how you define the name. And we want this computation to be done on a quicker fashion. We want that to be done in some small amount of time. And this function that you define should be uniform and randomizing in distributing the names. Now, how can we achieve this? So like you have a data structure course in your curriculum where this definitely would be addressed by your respective teacher to implement, like, okay, how this hash table can be used. So maybe you can ask your teachers rather if they haven't addressed this part to talk about it mainly. If you don't get any information set till 25th, let me know. We will arrange somebody rather to address that part so that he or she can cover up that part for you peoples. How to define this hash table. Okay, now let me move further. Now when I said hash functions might be, there might be different hundreds of ways rather that you can define. But we want that function to be a proper function which would be an efficient one. Now how I can go with this hash table, even like if I make use of this hashing technique, there is another option also available with hashing which is called as bucketing. Recall, like while we worked out with probability kind of problems, we were told there are n number of balls and you have 3 number of buckets. Okay, and they are of different colors. You have to put appropriately the balls into different basket or bucket available. Okay, so red color ball would be put in red color bucket so as to count very fast how many balls are there. That would be very easy for you, correct? Now further, like if I say if the size is varying, suppose I am having all red balls but size is not same of the balls, size is varying, so I need to have different buckets. So again there would be a linked chain added with that bucket. So bucketed chaining. So chaining would be probably there. So I have different buckets now included where they are varying in terms of size. Correct? In terms of size. Now if size is size of that particular variable. Now when I say size, how exactly I'm going to define this? So let me address that part too. Now whenever if you recall, I asked you how you define an identifier. So some of the programming languages had constraints. What would be the number of characters that you use to define an identifier? Now think of this, like for example, I have added a column here called name. Now how many characters this can hold? So generally you say name of 80, like this is our programming habit because of C, we say char name of 80. What that means, 80 characters are allowed. What if it is going beyond 80? Now when I say 80, suppose if I define this size to be 80 characters, if I have variable A to variable name to be A or identifier name to be A, actually I am wasting 79 places. 79 memory locations rather, because 80 characters are associated with each entry for that name. So I may have my names stored in a different fashion. So that would be kind of technique that I may use. So whether my name is identifier name is fixed length name or variable length name. Now what would be difference here in respect of implementation? How will you implement a fixed length name? Like the way that I said name 80. This is fixed one. You cannot have your name can be smaller, but you cannot definitely have more than 80 characters. Okay, so either it would be too little or too much. Correct. So you define like that. That is the reason like why we declare our variable names to be I, J, K, A, B, C, D, and so on. It is we are not talking about space at all. We are talking about easiness for us to remember what are the names of the variables that we gave. Now suppose we complicate that naming criteria by making use of some standard notation technique or symbol definition technique or symbol defining technique, then naming technique rather I'm basically addressing that. So if I use specific somewhat difficult one, then it would be very hard for me to remember, okay, how exactly I'm going to rectify what is the type of that variable. Correct. So other option probably for me could be make use of variable names. Now, how will I implement this? So I may say, like whenever I am talking about a string, if I arrange them in an array, okay, that array will have an index, name index. I'm saying name, which is varying. So for example, I say char star name or cat double star name for a while to store information about all such names. Correct. So when I said 80, ultimately I'm talking about this, say 80 by 80. So this might be your fixed size. Okay, where you will have this will limit number of entries and this will limit, say for example, how many number of characters probably could be there. Now to overcome this aspect, I may go with a variable length name where a string of space is used to store all names. And here we will be having index, which will be differentiating where the name exactly is starting. And for every name which is added in that space, empty space, you will associate two attributes. One would be length and other would be starting length. Say for example, if my say for example, if I talk about this printf, so printf started at 0, number of characters used are 5, sorry 6, 1, 2, 3, 4, 5, 6. This is length. Then I had a next over here at the sixth location. Its size is 1. So next I am going to have 7. Okay. So I will have say variable as say PQR, for example. Now this PQR would be stored as it will start its entry at 7 and length is 3. So this is how I can control naming as well by making use of variable length name. That is solely depend on our decision of yours whether you want a fixed name, length name or variable length name, because this will complicate your data structure if I follow this variable naming criteria, variable length name criteria. Correct. Now other aspect would be the scope. How will you identify the scope? Now when we do talk about the NM output, we said that probably there could be associations with respect to whether it is part of data section, whether it is part of text section, whether it is undefined and so on. So when we filed with NM, we got to know different things. We got to know small t, we got to know small d, we got to know capital D, we got to know B. There could be multiple parameters which can be defined for scope perspective. But whenever it is global, so whenever it is global, ultimately it should be part of some text section. Like in the example that I showed, we had two files. The LP label that we referred from the other file was part of another section, text section from that file. That's why we could see T displayed there. But if it is different, then it's okay. But if it is same, then ultimately it is going to create the problem. Because you said global LP and you are using LP. Now, if you don't say global LP that way, if it is not a global variable, then ultimately in such a case, this would be treated as local. Now in assembly, nothing is called local. Assembler perspective. But if I talk about the C function, suppose I have A function and PQR function. If I define I variable in A and PQR is containing also I variable, we know that scope of that I would be either A or PQR. But anyway, they would not be available to the outside world. Why? Because they are local variables and they would be found on the stack itself. So when I said that if I have two different files or more than one file rather, where I need to link together all of them. So do I have to create multiple symbol tables? Likewise, for example, if I try to show you this, okay, let me shift to my Linux machine. Okay, now suppose if I display this NM output with first as O, This is my output and this is another output. So in both the cases, you see LP defined, correct? Because that's how we wrote the code. One of them is extern, though we defined it as a label, jump LP. Correct. Now, if I remove that LP label from here, say for example, if I go back to my code and if I remove this label LP, okay, now let me try. Let me assemble the code. Yes, so I got it. So if I write nm, now you will see this u, correct, which is undefined now because I removed it and we wrote u extern and even we used it inside the code. Now if I try to link both using GCC, correct. Now if I try to display this out, now you will see that this LP entry is found only once and it is telling that it is part of a text section. So ultimately we had two different symbol tables. So is it better to keep both the symbol tables included here or we should combine them together? You may see here, see the addresses that are added here. Okay, see the addresses that are added here. A0, then suddenly I got B0. That means probably it could be the next address or next entry inside the table. If I go with read ELF, sorry, read ELF dash S A dot out. Okay, now see this A0 and B0. That the value, the address associated with them would be this A0, B0. Now, what exactly we can see here? It combines symbol table from both the files. So whether are you going to combine both of them together or are you going to keep them separately? That would be one another important problem that you need to resolve. Right now, we may not be interested in talking about combining two different symbol tables altogether. But what if this situation occurs at the later stage, if you are planning to design your own linker the way that you have seen before a while that I used the GCC command rather to link two different object codes, which in turn combined both the symbol tables together. Correct? So let me show you how. So let us say I have this code. I'm defining text section, sorry, data section here, section dot data ATD10 section dot BSS. So I'm defining another variable b raised d10. So both of them are double. One is initialized, other one is uninitialized. Okay, now let us go to another code. Emax 01. So I am defining here j section dot bss j raise b 100. Okay, now let us try to assemble them separately. So NASM this. So if I see now NM 17.8.21.0, you see that I have these two. One is from data section, other one is from BSS. This is pointing that data to us. You can see the code 17.8.asm. One we declared here as data part, other one we declared as BSS part. So that's why this D and B is shown. This is data part, this is BSS part. Similarly, if I try to assemble the other code, so let us see nm01.0. You can see that it is showing this J. Now see the addresses 0, 0, 0. Here also 0, 0. Now if I combine both the files together, so even if you use read elf dash s 17@equiz.o and _1. Now you can see here addresses are seem to be 0 only. Okay, for A, B, LP, this is undefined. Okay, and here also. Now let me link, and if I try to generate show now my symbol table. Now see, first, like if I go above, all variables pertaining to your one file are added here. So this was the original file, like 17.8.21.0. Okay, and then the second file was picked from the BSS part. And then actually your code section started. So it took from second now and then first. Correct? So your symbol tables are combined. So problem in front of you would be what? If at all I am planning to design this symbol table. Okay, whether am I going to have it separately? Let me show you another part. Okay, now can one file contain more functions? Let us see. Functions I mean to say procedures. Here we wrote only global LP, PL, QR, GZ. So here I am writing PL, rate, QR, rate, GZ, rate. So I am adding now 4 names over here. Correct. So let me save this and let me assemble this. So we want this to be assembled. Okay, now let us see the NM output. Now see, all of the variables are seen there and they are part of text section. Okay, now if I try to combine both together here, both the datos, and if I try to generate now or see the symbols of a dot out, now try to find out whether GZ, LP, PL, QR, among them how many are shown. So all of them are shown here. But actually they are not used anywhere. We are not referring to them at all. If we are not going to refer them at all, why exactly they are part of it? So if I go now to read ELF dash S a dot out. Now the entries are added here, like a GZ, QR, okay, PL entries are added, but actually they are wasting the storage space, because if you may have function defined, but if you are not using at all in the executable, then why you really want it? Correct. So let me try this. If at all I can achieve this. Even my optimization doesn't work at all here. Right? Because the kind of code that I wrote. So you may have some kind of code written like this. So you have multiple function definitions added, but if you are at all you are not using them, they are wasting the storage. Not only from the disk, on the disk for the executable perspective, but also the memory part when the execution is done, because they would be occupying some amount of memory. Like one can see here, like see how many places are given. So we had A0, then A3, correct? Then we have A2. So whether it is going to give how many bytes, rather probably if it is giving one byte altogether, then how exactly I'm going to organize this? This would be like you can see this A1, A2, A3 are the entries. A0, A1, A2, A3 are the entries with respect to the definition that is found inside the code. See the order. LP, PL, QR, GZ, correct? LPQG. So let us go with this. L, see where is L? LP. So this is 0. Okay, then we had what? After L we had P, correct? See here P, then Q, then GZ. See P, after L it had P. So this is A1. Then it had Q. So that's why A2. And then GZ. That's why A3. So it is following some kind of mechanism rather to store this information in the symbol table. But ultimately, like if we know that they are not going to be useful, why you want their entries to be available there. So this call we may not be able to take. That call is to be taken by finding out the efficiency of the code. Now, how exactly you will find out efficiency of the code at all? This efficiency of the code can be found with respect to the data structures that you use inside. Whatever the entries that are added which are not used at all, they should be removed. They should be removed abstractly. Now, if they are to be removed, then we definitely will be requiring some kind of operations which would be useful rather at that point of time to really address this issue of the symbol table. Correct? Okay. So any question till this time? Yes, please. Now, what do you think? What would be the pros or advantages of having multiple symbol tables? It would be easy for us to store information about the scope. Correct? What are the scope that we have defined? Like this is associated with this file, this is associated with this file, and so on. File, I mean to say the function. Okay, but disadvantage would be what? Whenever new thing is to be added, we need to find out, oh, is it available there already? You don't know. Because what are the naming criteria that you use? Suppose you started following the criteria applied by, say, for example, Windows, or applied by, say, for example, your first code. So for example, GCC, let me take example of GCC. If you start seeing the naming criteria used inside and you start defining your variable name that way only, can this happen that you are defining some variable name which is already part of a library? Then that would be really difficult to define what would be scope of it. Correct. So either you define the limitation in respect of how many variables could be there inside the code, or you keep it varying depending upon the requirement, keep adding this symbols. So it would be better always to have a single symbol table. Now what could have happened? Suppose if the translator is keeping like while the linker is keeping two different symbol tables, while I am displaying NM output, what it should show? Should it show separately symbol tables for each entry, or it should go with a single symbol table? So right now, whatever the output that we saw, it is showing it as a unique symbol table. Which advantages of it would be what? It is not wasting much amount of space. Yes, definitely overhead would be there to combine both and to find out the scope. Correct. Now, what are the definitions that we got into the symbol table for the functions for the labels that we added in the example, sample example which we discussed before a while? Overhead is what we have to find out. Okay, is it there? Is it there? You have to check at every entry point, and then only you can add. And you cannot easily close the scope. Close the scope, I mean to say, unless you reach to the final end point of every source code included when you are combining more than file, then it would be really difficult part. Close the scope. Correct? Now, what would be other alternatives for me apart from this? With respect to the symbols that you are adding, say for example, when I declare my symbol type to be, say for example, like this. So how will I identify that this is variable which I can use for the specific instruction? We saw that if at all I want a division to be displayed for two variables, we use a div command. What if the division comes in real number like 3.4? How it stores it? So we saw that it doesn't store the fraction part. So I may have to make use of then separate instruction set. So that instruction set is called as floating point instructions. Okay, so to take care of this, your architecture has something called as FPU, floating point unit, to handle all operations associated. That means what? your operations in this case are not overloaded. Like for example, div knows it has to work with integer, and fdiv knows that it have to work with only float divisions. But maybe there can be some association. Like for example, if I talk about C language, my plus operator can be used to add values of two integers, value of a variable of type integer with an integer value as an immediate data. Value of integer can be added with a floating point value as an immediate value, 1.2 say for example. So it is done that way. So that means your operators are actually overloaded. The operations are overloaded. Same thing can happen with your function call too. If it is recursive function call, then how will you handle this? Though we haven't addressed that recursion part, but this question definitely would arise whenever you are trying to design your own say translator. It could be a compiler. Then if your compiler is supporting, say for example, recursive functions, then ultimately you need to really think of how will you implement that mechanism for representing these kind of identifiers. Correct? So definitely there would be huge number of issues. Other aspect probably could be, say for example, you are going through the code. You identify now how will you make the entries into symbol table? So say for example, you started with say the code. Okay, what are the code that you had? Let me go to my code. Suppose this is my code. Let me pick star.asm dash ltr lace 090821.asm. Now if you see this code, it is pretty easy. Like I don't have anything involved apart from main. Correct? In the code that is shown here. Now let me go with this. Let me edit this code. So 090821.asm. Okay. Now what I'm doing is I'm showing you at the same time the symbol table picture which we created through Excel. Okay, on the other machine. Now suppose you have, how will you start adding the entries into symbol table? So let me say I have section.data, say A DD10, B DD20. Suppose I added this, correct? Now somewhere I am getting this as LP. And here I am having PQ. Fine. Okay, now suppose code is like this. And PQ is somewhere here. Fine, so I'm switching in between now with my code. Okay, so let me first copy this code so that I can show it at one place only. Okay, let me send this file through the chat window so that you also can use this. Upload from my computer. Okay, so I'm moving to my original machine. Let me show that part. Okay, so let us go to chat. Okay, so this is the file that I have. So let us say we will keep this here. Fine. We'll keep this here. So this is our file. Now say, let us say we started constructing adding this, populating the symbol table. So we got first entry to be A. So let us go to our symbol table. So let us say name A. So I am saying type DD, size 4. So I may have column as value 2. So value for that variable is what? 10. Uh, Suppose I am keeping it here. Found in data section defined. Correct? Now its entry in the symbol table, like I am adding say a pointer. OK, this would be serial number. So at point 1, like first entry is that. Now I got second variable in my code. Second variable is B. So same way I will try to populate it. So B DD4D. So let me copy this. I got 20. Fine. Now third thing, if I go to code, I got global main. So I go here. So yeah, I got main. Type is say I'm saying label. Size I don't know. As I found like global main was written and then I wrote main colon. Correct. That's why it is defined. Scope found in text section. Value nothing. OK. Now I got next. So I am getting JMP PQ. Now I will try to find is PQ there in this code? No. So I will add. Sorry, let me add this. I will add PQ. So it is saying label. OK, size is not known. This is undefined. OK, found in text section. OK, value nothing. So I got move EX comma EBX. This I will skip. I got LP. So I will see like this is line number 1. Jump PQ. This is line number 2. This is line number 3. Correct. Now this is line number 4. So I will try to add like this is line number 0. So I can say here value to be 0. Correct. So get attribute, set attribute. So I'm setting this attribute now value 0. Now I got next label as LP. Correct. So we got LP. It is a label. So let me copy first this. Now it is found with colon. That's why defined. And its position is what? Now this is line number 0, 1, 2 and line number 3. So I'm putting here line number 3. Ultimately computation would be how many bytes are required to store this. So say 2 plus 2 4 plus 2 6. OK, so 6, then this would be 6. Correct. So 0 to 5, 0 1 2 3 4 5, then this would be 6. Correct. That's how I added this L3. Now I'm moving further. Increment DCX. This is gone. This is gone. Now I got PQ. I will try to check whether PQ is there. I found it. So now I came to know that it is U. Correct. So when it is U, so then I will find. So this was 1 0 1 2 3 4 5. So I'm writing line number now. This is at line number 6. So PQ entry. Then I will convert this. Get attribute. You got U. Set attribute, say D, get value, get attribute value dash set attribute value 6. Correct. That's how you would be manipulating. Now what if your code contains another LP here? For example, this PQ is replaced by LP for a while. What it will be doing? Say for example, suppose if this entry is not at all available with me. Correct. This entry is not at all available with me. I got LP in the initial phase, like seeing the code here, and again I am getting LP. Now assume that this PQ is replaced by LP. I had already LP, so I will try to find out is LP there? Yes, I found it. And what is the status? D. So it says multiple defined. OK, let me show you through my assembly code too. Let me check this and then 1 minute. I'm making the change in my code and let me switch back to my Linux machine now. OK, now let me show you the code. Emacs. So what I did here is I added LP twice. So what we did was when we got this first LP, we added that into symbol table with definition to be D. Defined D. Yes. If I get another LP, then what? Let us see. If I try to assemble this code, NASM dash APLF 32 0908 21 dot ASM. Now you see this originally defined. This is what we saw, correct? This is note, but it is giving you error. Inconsistently redefined. That means multiple definitions found. So where exactly it traced it? It tried finding out that part into the existing symbol table, whether it contains an entry of LP or not. When it found that LP entry, then it said, OK, now yes, I cannot proceed further with respect to your symbol table. Please go on. Now let me add a few more things here in the code so that you can see how this is handled. So let me remove this label now. OK, and add one more LP here. How many times the error should be? Error should be 2. OK, twice. Rather, when one was defined, it was showing at line number 13. It was redefined. So I should see another line number with that same kind of error. You can see this. And line number 17 again I got this. That means what? It reaches to the last line and then it terminates by displaying the errors to you. Correct. So this is how your symbol table is managed internally. So when we talked about the aspect of the label that we used inside the code, okay, on my machine, rather this one. So when I do talk about this particular aspect, let me go here and let me make this black. Now you see that like earlier, whatever the PQ entry was, this was U, correct? As per our code or as per our definition of the program. Now here this PQ is not defined yet, but is referred. This is forward reference. This is forward reference. Somewhere, suppose in front of PQ, if I write LP, jump to LP, then that like LP is already defined. Then you are going to call or you are going to pass the control on the backward side. So this is backward reference, forward reference and backward reference. What is forward reference? You are getting a definition which is not declared yet. And you are getting declaration which is defined already. Correct? Two things. One is what? You got definition, jump PQ, it is not declared yet. Forward reference. You saw LP declared already. But whenever you are trying to write jump LP below somewhere here, below the code, before after the definition, then this would be backward jump or backward reference. Correct. That's what like, even at the time of translation using the earlier part when we used Intel manual, we saw that whenever there is a forward jump, it counts the number of bytes. Whenever it is a backward jump, then it goes with 2's complement mechanism. Correct. That is how the forward and backward references are handled internally inside NASM. Okay, by making use of this aspect. Is it clear now how to build the symbol table and how the entries would be there added? Any question, please? Yes. Any question? Akshay, Borole, understood it? Sakshi?
Sir, can you show in Excel sheet for backward?
Yeah, 1 minute. So we had this PQ, correct? We had this PQ. This was undefined because this would be forward reference. Now, when we saw this LP, say for example, this LP came. Now, suppose I haven't written here like go back to LP. Okay. In that case, what will happen when it goes on, moves further, collects information about LP, entry would be added here, correct? Like this, which is defined. Now, when it reaches, say, for example, somewhere here, and suppose let us assume that after this PQ colon, we have written jump LP. This would be backward jump because we already had definition of LP with defined status. This was forward jump before we reach to the PQ line, like what are the line that we added here in the code. Before we reach here, till this time, it would be U. When it reaches here, then it would be converted to define. That means found, entry found. Okay. Understood?
Yes, sir.
Yeah. Any other question, please? Can take screenshot of this, by the way. Let me try. We will be able to print it. I added for your reference, like how it may probably look like a sample case with the code. Okay, even let me add this code. Though I haven't updated my symbol table after finding this PQ entry. Okay, after finding this PQ entry, if you see, I haven't manipulated this U. This will be modified to D rather, like when it identifies that. So this would be D, and that's why this entry could be 6. Otherwise, it would be what? It would be U. Okay, found in text. No, correct. Found in text and address is not known. So that's how it would be before. Correct. So dash. It would be like this before it reaches to the conclusion, like last line. When it reaches to that last line, then ultimately your mechanism would be changing. So this would be like one the recent image that I added was before it gets definition of PQ. Okay, that time it is U. Now after it is found, then what will happen? This, sorry, I will manipulate this. This will become D and this will become 6. So let me delete this one. I don't know. Let me try deleting this. Okay, I'm not. I don't know rather how to delete it. So after the forward reference is resolved, then this would be the picture. Okay. Any question apart from this?